Okay, hello everyone. Welcome back to the new lecture of physics in class 9th, that is force and laws of motion. Right, so we have discussed so many things in motion topic. Like we did many questions, we understood many of the concepts which were important. So okay, now in class 9th we have another aspect. Initially that was the kinematics part. We were trying to understand how the body can change its state, right, whether the state of rest or motion, right? But here in this chapter we will understand that okay, how we gonna change, like what is the cause behind the change. So this comes under the part of dynamics, right? Dynamics in mechanics. Okay. So initially in class 9th there is no such kind of kinematics or dynamics, but I still want to tell you because eventually you guys gonna learn in class 11th, right? So the chapter name is force and laws of motion. So what gonna we exactly discuss here is the type of forces, right? I know that in class 8th we have already discussed the type of forces like contact force, non-contact force, gravitational force, electromagnetic force, frictional force. In some of the schools, in some of the classes we have discussed like tension force as well as normal force as well, right? But mostly we have discussed the most kind of forces, right? But we have to understand more, right? What is the significance of the force, whether force is a scalar quantity or a vector quantity, okay, how the thing started, like why we, these laws of motion, when we talk about these laws of motion, who made these laws? Obviously everybody, most of you know that this was made by Newton, right? But before Newton, was there somebody who did the experiment, right? So all of these things for which there are certain basics to understand, to realize, to feel. No, that is why like this is physics is not just it's not a subject, it's an emotion, right? So what do we gonna do is we only do not understand it, but we also feel it. Like for me, physics is a kind of feeling, so that is why you must be thinking that why sir has written understanding cross but feeling tick, because it's a kind of emotion to me, and I really want everybody, all the viewers who are viewing this, that don't consider physics as a subject or the toughest subject in the world. Consider it as like an emotion, right? It is very, obviously it is very close to me, because everything today I am giving this lecture, talking to various students, changing the lives of many of them. This is because of the only subject which I teach, and that is physics. So physics is a kind of everything to me. It's like a religion to me, it's like a god to me, it's like an emotion to me. So that is why with this thumbnail I just came that it's not just the understanding of the subject, it's a feeling. So what we're gonna feel today, okay, how the force came into play, how the topic related to force started, this is what we're gonna feel today, okay? So let's start with the topic. So exactly what we're gonna discuss is the laws of motion, cause of motion, and balanced and unbalanced force. Now what exactly is balanced and unbalanced force? See, initially in your class, in class 9th, in class 8th, even in class 11th, how do we define force? Okay, so force is defined basically like, suppose this is my phone, right? So I am pushing it like towards, I'm pushing it away from myself and pulling it towards me. So this is how I define force. Or even in the classes, like even in the NCERT books, it is written like force is push or pull of an object. So everything, like any force we are applying, it is producing basically the two effects. Either we are pulling the objects, right, or we are pushing them. So again, right, this is very close to the real life, because in real life we should pull the positivity and push away the negativity, right? We should pull the good people in our life, successful people, mentors, those people who can do good to you. We should pull them towards us, and we should push away all the negative people. Obviously the people are not negative, it's just that it can be negative for us, right? So now again I'll say that physics is very much related to the life, right? So how do we define force? Force is either push or a pull of an object. So it is not just whether, like suppose if I'm lifting something, so I'm pulling that object towards me. So even the lifting something is also due to the applied force. Now the question comes that, can we see force? No. If I'm applying force to any object, you cannot see it. You can see the change in me, that okay, I'm applying the force, but exactly force cannot be seen, right? So how do we often get to know that there is the force, right? Sometimes when I was very young and I'm not studying, my mother just looks like me, okay, you have to study. She doesn't say anything. She's just like standing and like this, she's doing all the time. So I get to know that intangible force. I get to know that yes, I have to study. Yes, beta, I have left Alan. You are Param from the JE batch, class 11th, right? Hi Param, how are you? I remember you now. You were in, if I don't, TP4 batch, right? Okay, so I'll just continue with till the time he replies, right? So what I was telling, like the force can be, yes, perfect. So how come you are attending this class? You are already in class 12th. Go utilize your time. Or maybe you just wanted to. Yes sir, 2024. Yeah, I know. I remember you, beta. I remember you perfectly. Small height guy with the specs. I remember you, Param. Don't worry. You don't have to tell the batch. So let's come back to the discussion. Okay. So force can be tangible or intangible, right? But we cannot see where exactly the force is acting. It's just the feel or the effect, right? Effect of forces. That is why in class 8th, there was a particular topic where we were studying about the effect of force. Here also I have added to my lecture, because I just wanted a small recap to start before starting the topics of class 9. I just wanted to make sure that you remember everything about the force, right? But eventually our focus will be on the class 9th the class 9 topics, right? So let's focus on that. Let's start. What is the laws of motion? Basically laws are the rules, right? And we need to understand what exactly motion is. So how the rules of motion to be written? Yes or no? So the first question is, what causes motion? Any force, right? Any force causes motion. Let me give you a very small example. Like suppose this is the example given in the NCERT as well. I just made it in, see this man exerting so much force to move the car, right? So he is basically pushing the object, right? And this push of an object, and this is being applied by the muscle, so this is a muscular force, and he is pushing the object or the car. That is why the car is changing its position, right? So position of any object is changed due to the some force. That force cannot be seen, but yes, effect of the force can definitely be seen, right? Here also you can clearly see that the man is pushing the car, and this change in the position of the car did what? We got to know that okay, force was there and this man was basically pushing the car, right? So force is push. In next case, see, if you take a look, right, there is a towing man and this car is being taken by the towing man. He must have parked it at the wrong place. That is not the point here. The point is that, you know, the towing man pulled this car, right? In the first case, it was clearly seen that, the man was pushing the car. But here it is pulled by the towing man. So when I say that force is basically what? A push or pull of an object, right? So force can be written as pull. Clear? Now, so cause of motion is force. Now, how this, in the first chapter we didn't discuss about what was the cause. Here we're going to discuss about what exactly the cause is, right? Okay. So simple push or pull of an object. This is defined as force, but yes, it is just for the layman or very basic definition that we need to understand. This is not the mathematical derivation. You know, when we'll study the Newton laws of motion, then we will realize that okay, Galileo and Newton did so much work to make a mathematical derivation, right? And that is very important. But for now, at your class level, at your standard, you can simply say that force is defined as push or pull of an object. That's it. In very simple words, but it is much more than that. A force has so much significance in every physics, like in everything, every object. In physics, force has so much significance, right? So force cannot be just defined in two words, that push or pull of an object. It is much more than that. But at this level, we need to understand that in simple words, because I told you that physics can be very simple if you try to understand it, right? So to make it more simpler, the scientists have thought that okay, we just give two words definition, so that every child, every student, every learner of physics should understand it. So basically, what is force? Force is push or pull of an object for now, not in class 11th. It can change. The definition will enhance itself, right? So push or pull of an object, this is clear, right? I showed you the example. One man was pushing the object, another was pulling, right? Let's come to the next part. Can force be seen? This is a very good question. Yes, we can see the person who is exerting the force. We can see the object on which the force is being exerted, but exactly do we know that where exactly the force is? No, we cannot see force. It is intangible, right? No, obviously, right? How do you know there is force? Then there comes another question, that how exactly we get to know that okay, there is some force. This is because obviously we see the change. We are always watching the change, you know. This is very related to the real life as well, you know. We often see the change only. We are only, focused on the change. And for human beings, it is mostly positive. You know, these constructions, these development, these new subjects, new rules, new science, right? New technology, this is continuously doing what? The change. And we are, are exactly seeing the change in everywhere. So how do we define that, okay, there was some force? By just seeing the effect or the change. Okay, so change is important, right? By its effects. Effects basically the change here. Effects basically the change, right? Okay, now what are the effects of forces? This obviously we have discussed this in class 8th. I am pretty sure about it. Okay, so when the ball is kicked, the ball moves. So what are basically the effects? I'll quickly tell this to you. You know, if a force is applied on the body which is at rest, it can bring it to the motion. First change, first effect. Second effect is that it can change the velocity. You know, if like let me show you the next. See, the next one, the ball is caught by the fielder. Now what exactly he did? He applied force and changed the state of motion to rest. So the first is rest to motion, second is vice versa, motion to rest. Both are done by applying force. Okay. Third one, change in speed or change in velocity, right? So how come we are changing the velocity? There is a case for this. See, you can clearly see that there are brakes. This is the brake and this is the pedal, right? So when like I am particularly very fond of this, car related movies or racing related movies. So when you put the force on the pedal, obviously due to the acceleration, the force which is exerted by us on the pedal, what will happen? It will change the speed, right? So basically this is the third effect of force, that it can change the speed. So first is rest to motion, second is motion to rest, third is it can change the speed or the velocity, right? Fourth is force can change the direction. I am very fond of cricket, very fond of cricket. So when the bowler is like bowling, so the ball is coming to me, right? The ball is coming to me, right? But because I am the batsman, I am hitting the ball, right? So what I have done, I have changed the direction of the ball, right? Also, definitely I must have changed the velocity. So two things are happening at the same time. So this is because of the force that is applied by me on the ball, because I am the batsman here, right? So force can use to change the velocity of an object. So other is the change in direction. You can clearly see, this is what I told you, that okay, this is the American cricket that we're talking about, but I was talking about my the cricket that we oftenly see. So force is used to change the direction. Change in shape, this is very normally we don't see this, because we oftenly deal with the rigid bodies. But yes, when you exert force on the balloon and it's not bursting obviously, then for some time, for some extent, its shape will change, right? Or maybe you have you have a metal rod, very thin metal rod, and if you try to, like, suppose, okay, I'll tell you, if I try to apply the force on this, this pen will break, then obviously I won't be able to write. So I'm not doing this thing here. But if you take a metal rod in this place of pen, you take the metal rod, right, and you try to apply some force, what will happen? You can bend it, right? So you basically change the shape, and that shape change was only happening because of the force, right? So this is the last effect, that it can change the shape also. Okay, and we call it as, like in class 11, we will call it as deforming force, deforming, right? Because it is changing the shape. So deforming force, right? Like you can also see, the potter is molding the clay into its desirable shape, what kind of a shape he wants, he is changing the shape, right? So these are the basic effects that we talk about, right? Force mold is used to change shape. So basically force is doing 5 things here, right? So the different types of effects of force are, so there were 5 kind of force. Okay, so I'll write here only. First is rest to motion. Second is motion to rest. Third is change in velocity, or in junior classes we can also say change in speed. So velocity or speed, because we are taking direction in a different scenario. So change in direction. But in senior classes you will prefer velocity over speed, because it gives you more information, right? Change in direction. And the fifth one is obviously change in shape. Okay, so these are 5 effects that you will see. Okay, now Are there different kind of forces? The next question is yes, there are different kind of forces. What kind of force are we talking about here? So there are two types of forces, balanced force and unbalanced force. Yes, now you must be thinking that there are different kind of forces. We are talking about the contact force or the non-contact force. No, we are not talking about that. This contact force and non-contact force already we have done in the junior classes, right? So we need to learn new kind of forces, and this is basically not new kind, it is the normal force that we're talking about. Only difference is that here we are focusing on the magnitude part, right? If the net force magnitude becomes 0, like if you total all the forces and the net force acting on the body is 0, then you call it as, okay, that it is under the balance condition, so we call it as balance force. Okay. Also, if the net magnitude is not equal to 0, like suppose there are 5 forces acting on an object, okay, 5 forces, and these 5 forces, if we add all the 5 forces, right, and the net of all the 5 forces are 0, then we call it as balanced. But if the net of these 5 forces are not 0, then we call it as unbalanced force. So what is the difference between the balanced and unbalanced force? These are not two different kind of forces, no. It is only dependent on the magnitude, whether the magnitude is equal to 0 or not. If the magnitude is equal to 0, that means the net force acting on the body is 0. That means there is no as such effect on the body because of all the forces, right? If there are like 4, 5, 6, n number of forces acting on the body and they are bringing some change, we can clearly see the effect, then obviously we call it as unbalanced force. So you understand the difference between balance and unbalance. So these are not new forces that we are talking about. It is not like that, okay, we have studied in class 8 that okay, there were 5 forces, now 2 more has come, so 7 forces. No, it's not like that. It is only dependent upon the magnitude, right? If the magnitude is 0, right, then on body there is no such effect of all the forces acting on it, then we call it as balanced force. What about unbalanced force? Unbalanced force is basically when the net force on the body is not equal to 0. Then obviously we can change, we can see, we can visualize the change, right? And once we visualize the change, that is because of some force, therefore we call it as unbalanced force. So it can happen due to the n number of forces acting on the object. Okay, I have made, like, I'll show it to you. So forces which are equal in magnitude and opposite direction. So this is not just the complete definition, but yes, for junior classes you can obviously write that. Suppose, let me take an example. So this is the game we used to play in our school, tug of war. You can here see different kind of student participating in this game, and here they are trying to win the game. So these students, the one in green, are trying to pull them, right? So they are exerting force in this direction, right, the green ones, and the team in the yellow are trying to pull the team with the green, right, in the green. So they are exerting the force in this direction. Now because this string, this wire is not moving, so if it is not moving, that means, suppose if this one is F1 force, okay, and this one is F2 force. So net force on this wire is how much? F1 plus minus F2. Why I have taken minus F2? Because F2 is acting on the opposite direction, right? Yes or no? Okay. Am I not audible? I oftenly get this comments a low voice. I feel that I'm quite audible because I can see it in the software that I'm audible. Let me just check. Maybe you guys are right. Let me just check. Right? No, I am perfectly audible. My phone was but I am receiving. Okay. Push of an object, and this is being applied by the muscle, so this is a muscular force, and he is pushing the object or the car. That is why the car is changing its position, right? So position of any object is changed due to the some force. That force cannot be seen, but yes, if it no, it's perfectly fine. It's perfectly fine. The voice is perfectly fine. Okay. So here F1 is acting on the left hand side and F2 is acting on the right hand side. So right hand side I have taken negative. So F1 plus minus F2 is equal to 0. Okay. Because the net force acting, there is no change. Right? If there is no change, this means that there is no force acting on it. So F1 plus minus F2 is equal to 0, or we can write F1 is equal to F2. That means if F1 and F2 are equal, that means this string is under balanced condition. So that is why we are saying that okay, F1 is equal to F2, and hence F1 F1 is equal to F2. I don't feel that there is why everybody is saying voice problem. Right. Yes, it's coming. Perfect. Now it's fine. Okay. So forces which are in equal in magnitude and opposite in direction. So basically F1 is equal to F2. Right. So when F1 is equal to F2, so it is under the balanced force. Okay. What about the unbalanced force? Let's talk about that. So in this case, you will see that now because the team members have been reduced, so this green team has more, okay, let me just check. Right, there is one doubt, but you have written the wrong equation in the comment. Okay, that equation is S is equal to ut plus half at square. I guess you are writing that only. Yes. Right. Beta, whenever you will solve, okay, let me tell you. So whenever you will solve this type of question, na, where you will be getting two time. So see, if one okay, I'll tell you. Listen to me very carefully. So this is the general equation, ax square plus bx plus c equal to 0 for a quadratic equation. This you guys must have known about it, right? So there are two roots, one is alpha and one is beta. So suppose when you solve this equation, s is equal to ut plus half at square, so you might be getting two, t1 and t2, right? Two roots. This is what you are asking about, right? I'll tell you. So when t1 and t2 is basically, say suppose one answer you got 4 and other answer you got -3, right? One answer is positive and other answer is negative. So you take the positive one because time cannot be negative, right? But sometimes what happens that you are getting 4 and 9. So yes, what is happening here in a particular question, that at 4 second also it was at the same position, and again at 9 second also it was at the same position. You getting my point? So If you are facing this problem, no, then you either neglect the negative one. This is one way. If you are getting one value positive and other one negative. Okay. Right? And if T1 and T2 both are coming positive, okay, T1 and T2 both are coming positive, then that means the same position, like it is the body is turning around. Okay, so this obviously right now in class 9th, I don't think that you guys must be getting these kind of questions, but I'm very sure that if you are preparing for class 11th, then there is a particular topic called turning point. So there you can see these type of questions, right? So don't get confused. If S is equal to ut plus half at square you are getting, then you can neglect the time which is negative, because time cannot be negative. Okay, and if you're getting both the time positive, that means both the time the position of the body is same, so it is turning around. Okay, so I'll continue with this. Right, so I was telling that now the team member has reduced. You know, in yellow side team there are just only 2 players, and on the green one there are 5 players, right? So 5 players are exerting more force as compared to the yellow ones. So now if this is, we call it as F1 and this is, we call it as F2. So F1 is greater than F2, right? And F1 is greater than F2, that means F1 plus minus F2 is greater than 0. That means the net force is on the left hand side and this team will win. The team on the left hand side will win. Okay. Okay, let me just see the okay, the person who has come with the ID from IIT Bombay, beta, this is the question that you can ask in class 11 when I'll start with the projectile motion. Okay, tomorrow probably I have a class, and tomorrow I'll be starting with the new topic, projectile motion. This is the topic of projectile motion, I know that. Okay, so anyways I'll be discussing everything related to the projectile motion. You can definitely ask. Then definitely let me just click the picture and this question I'll definitely clear. Okay, so I have, so the person or the student who have joined from IIT Bombay, I have taken the picture. See, I have taken the picture and definitely I'll clear the doubt. Okay, this is a very basic question. This we will be covering in the tomorrow lecture only. Okay, please solve, sir. Tomorrow, just wait for tomorrow. Right, this is class 9th anyways. So class 11 topic cannot be discussed. We have certain limitations. So tomorrow for sure, I'll just share the link, join, and you will get the solution, I promise. Okay, chalo, should I continue? Right, so this is unbalanced force. Here F1 is more than the F2. Okay, clear? Now coming to the next topic. So you can clearly see, let me just erase my annotation, and you can clearly see here that okay, this green team is exerting the force, more force, therefore they have pulled this yellow team here, right? Now force, see, force is somehow related to acceleration. Let me tell you a very basic formula that you should remember here only, that force is equal to mass into acceleration. So somehow exactly there is some change in velocity, right? And change in velocity upon time is related to what? Acceleration. Yes or no? I'll also tell you how this force is equal to ma came. It is very early to state that. Okay, and yes, we are, see, in the last chapter also, if you have seen all the lectures, then we have solved many numericals, right? Like we have done enough numericals that were related to the chapter 1. So what's the pattern exactly? That we go with the basics first, and then we go with the theory, we go with the derivations. So it is happening step by step. Okay. So remember, like you can check with the last lectures, we have done like so many numericals related to the topic. Okay, right. So now coming to the next topic, how, when I told you, when I started the class, I told you that we exactly know, you should know the history as well. We should exactly know the history, that how, this force came into play and everything. So it started with the Galileo, right? There was a scientist called Galileo Galilei. He was a very famous scientist, right? Though he could not give the laws, so it was eventually given by the Newton, but this laws of motion was actually started by Galileo Galilei, right? So when we talk about Galileo Galilei, he started it with an experiment, and let me tell you that experiment. And this is the experiment given in the NCERT as well. I took it from there only, but I made a little bit more pretty, more knowledgeable, more technical advancement I did, so that you can exactly understand what he was trying to do. Okay, so what exactly he did, he took a ball and he took two planks, right? You can see two planks here, right? And you can clearly see a ball. So what he stated that, if I like allow this ball to move down, then it will again reach to the same height. This is what Galileo was trying to say in his experiment. Right? So this was the experiment performed by Galileo. What he was trying to do, that he put plank with the same angle, and now he told in his experiment that yes, they are achieving the same height, right? They are achieving the same height. So the ball is coming down. See what exactly he was trying to explain is the conservation of energy. If you think differently, you can clearly see that here the conservation of energy is happening. How? I tell you, at some height there is some potential energy, right? You guys must have studied about potential energy and kinetic energy. Maybe you got some idea, yes or no? So this ball, because of some height, had some gravitational potential energy. Okay, now when it was freely left, it moved down. That means this gravitational potential energy was reducing and the kinetic energy was increasing. Okay, again at this height, kinetic energy got transformed into potential energy. So Galileo wanted to explain that, okay, if I drop the ball from some height and I allow it to move, it will again reach to the same height. Though he was not, exactly what he was not referring to was the frictional force. This exactly does not happen because of the friction force, but here they have taken an ideal situation. Initially it was an experiment, so it was based on some thesis, right? So this was the first thing that he told, that okay, it will reach the same height. Next he told that if I rearrange the plank, if I reduce the angle of the plank, this is how I did, right? So it will move some more distance and it will move some exactly the same height. See, initially feel the difference. Here also the height was same, right? When I changed the angle of, when I didn't change the angle of the plank, the height was same. But even after changing some angle, the height achieved by the ball is same. This is what he told him in his experiment, right? And eventually, if I gradually decrease this height more, this ball will move to the infinity, which is not real, obviously, right? Yes, this is the first law of yes, the voice is clear. I don't know. like I'm really thankful to you guys that you guys are keep commenting that voice is clear. Otherwise I get so distracted because of that okay, my voice is not clear, but eventually yes, it is clear. So let's continue. So this is, just see, look at this. This ball is moving till infinity, it's not stopping. So this is what exactly the Galileo thought, that okay, there is no friction, or this was his experiment. But eventually he was unable to give a mathematical significance to it, right? So this wasn't accepted, but this was taken as a thesis for Newton. Yeah, like Newton used these things, and he based on the basis of this only, he was trying to understand that okay, I can use this and I can realize that okay, how there is a change happening, right? So in the right side plane where the ultimately made horizontal, the marble would continue to travel forever, trying to reach the same height that it was released. The unbalanced force on the marble in this case is 0, right? Obviously there is no force, but this eventually does not happen. This is not the reality. What was the reality which we still study today? That is the Newton's law, right? So Newton improved this thesis of Galileo, not proving him wrong, but he modified it. So Galileo, what did Galileo deduced? So Galileo understood that objects with a constant speed, when no force acts on them, yes, we are very clear, when there is unbalanced, if there is unbalanced force on the object, then only the velocity will change. But if the force is balanced, right, then if any body is in motion, it will move for infinity. But obviously in reality there is friction force, so anyways there is unbalanced force, right? But this is the first law which Newton told us, which obviously Galileo was not able to explain because of its less mathematical significance. So Newton told us that any object which is at rest or any object which is at motion will stay at rest or motion until and unless there is some external force applied. And he told the reason that this is the reason because of its inertia. Now what exactly inertia is? So coming back, we will discuss obviously what inertia is, but eventually Galileo was the first person to tell that if there is no force acting on an object, okay, also he told that if the balance force is there, sorry, like suppose the net force on the body is 0, so it will maintain its original velocity, which is eventually right, okay, neglecting the frictional force here. So this is what Newton told in his first law, known as law of inertia, right? That any body which is at rest or any body which is at motion will remain at rest or motion until and unless an external force is applied. So this is what he did. He gave to the world in very simple words, right? A body will remain at rest or at motion. Until and unless you tend to change that state, right? So I hope that this Galileo experiment and the analysis done by the Galileo was very much helpful for Newton to make these laws. So I hope that this topic of Galileo, because in NCERT it is very limited and it is not very clear, right? So that is why I chose this experiment and I wanted to discuss about this, because this is the history of motion. This is how motion exactly started, okay? Coming to Newton's law. Now basically what do we have here is that Newton represented 3 laws, right? So we'll be discussing it one by one. In the first law, I already told you that it was with the help of Galileo. But Galileo was unable to give the mathematical significance, whereas Newton gave. So we call him, his complete name is Sir Isaac Newton. Obviously, he has so much given to physics, so many theories given by him, a very important discoveries done by him, especially in mechanics. Everything that we study is mostly because of Newton. Okay. So coming back to the Newton's 3 law, we'll be discussing this one by one. So first law, known as law of inertia. Okay. Now what is inertia? I give you a very basic example. Like suppose, though I don't have a younger brother or a younger sister, but suppose it's 4 a.m. in the morning, 3 a.m. and my younger brother is asking me for a glass of water and I'm sleepy, right? I'm sleeping, it's midnight, obviously. So what should I do? Should I give him the glass of water or should I avoid him? Obviously, most of you will say that avoid him, right? This is what I did eventually and hypothetically, not in reality, but you need to understand this because it was too heavy for me to bring that change in the midnight. Obviously, he might have asked the same thing in the evening time and obviously I would have given him the glass of water, right? But at 3 a.m. midnight, he is asking that I need a glass of water. So what will I say to him? That I won't give you. I will deny eventually because I am sleeping. This is because at that particular time, the change he wanted to bring to my body, because I have to wake myself up, I have to go to the kitchen. That was so many tasks. No, I don't want to do that. So basically, there was some inside resistance eventually. That is why I didn't wanted to give him a glass of water. This was the property of an object. What was the property of an object? That I resisted a change. Obviously, I don't want to change the position. I'm sleeping and he's asking for a glass of water. How is that possible? It's not possible. I cannot give him a glass of water at 3 a.m. Same thing he asked me at 5 p.m. Definitely done. Okay, you are my younger brother. I love you. I can give you a glass of water, but not at 3 a.m. Right? This change which he was asking, that was a very big change and I was resisting. Right? Similarly, in physics, depending upon the mass, right? Like suppose I have a vehicle, I have a bicycle and I have a truck at the same time. If I apply small force on a bicycle which is parked, in the parking it is there and it is on the stand. If I apply a small force, it will fall down, even with a very small force. But if I try to apply same force on the truck, there won't be any change, negligible change. Why? Because of their inertia, right? So inertia is basically the property. You need to understand this statement very carefully, that inertia is the property of an object. What does this property do to the object? It resists. Resist what? Change. What change? Change of rest or motion. See, for an object there is no change, like we are not changing the shape. We are not doing anything. We are just changing the state. State means either the state is at rest or at motion. Okay, getting my point. So, because of the inertia of an object, now inertia is the property of an object, because of which it resists the change. What kind of change? Change, either it is at rest or motion. Now, this whole property depends upon the mass of an object. Now, this is the beauty of physics, that all this property which is happening is directly proportional to the mass. More will be the mass, more will be the inertia. So if you try to lift a heavier object, you need to apply more force. Why? Because you need to bring a the bigger change, right? You need to bring a bigger change. But if you want to lift a very small particle, very small object, it is easy for you to pick it up, right? But if you want to lift a heavy bag, 20 kg bag, it is bigger task. Right? Why? Because you want to bring a bigger change. So you need to apply more force. Clear? So now how we are deciding that where we need to apply more force and where we need to apply less force, that is somehow related to the mass, because inertia is directly proportional to the mass. More is the inertia, more is the mass. More is the mass, more is the inertia, obviously. So if I ask that I suppose if I apply 10 Newton force on a bicycle and 10 Newton force on a truck, what will happen to truck? Nothing. What will happen to bicycle? Maybe it can fall, right? So this we need to understand, that more force, why we need to apply more force, or why we need to, where we need to apply less force, depends only on the one property of the object, that is called inertia. Okay. Now, inertia is dependent. Yes, please ask question. Please ask question. Obviously, this comment section is for asking questions only. Right? Please ask. So, inertia is the property of an object through which it resists its change of rest or of motion, and it is dependent on mass. So, you need to remember more is the mass, more is the inertia. So, let's just take a look. Means, inertia means to resist, right? Obviously, resist the change. Inertia is the tendency of a body to resist change its state of rest or state of motion. Okay. Now, this is a very good example. You must have seen many people on YouTube making the video of this. You know, okay, I tell you a story on this. So I have seen one video where there is a table and there are some utensils kept, and this tablecloth was connected with very big string, and that very big string was connected with a car, some hypercar. Okay, and this experiment was done by that car. That okay, they accelerated the car, and along with that they took the tablecloth, not the utensils kept on the table. Amazing video I see on the YouTube, right? Okay. A body is accelerating in a straight line, the unbalanced force acts. Okay, is this a question, beta, or you are telling? Sir, please this answer. Okay, I'll tell you the answer. But is this a question? A body is accelerating in a straight line, the unbalanced. See, I tell you a very basic thing, remember. If there is some acceleration, there is because of some force. Change in velocity happening for a reason, and that reason is the force. Okay? No force, no acceleration. No acceleration, no force. See, force, I tell you, force is basically dependent on two things. Mass and acceleration, right? So more is the mass. I mean, if the acceleration of the body is 0, force is also 0. If there is some acceleration, okay, you got this question. Okay, and this was the easy one. You should have asked some, study more, ask better questions. This is a very basic question. You should have understood this, right? So it is somehow related to the acceleration. Change in velocity happening, that means force is there. Okay, remember this. Very simple, right? So I was telling you with this example, you should watch this video. This is amazing, right? So this is how they what they exactly did in this video. They pulled tablecloth so quickly that these utensils were not able to realize that okay, there is a change coming. Okay, so because of the inertia, they stayed on the table only, and we were saved by our mothers, because my mother seeing this experiment doing with her crockery, then she's definitely gonna kill me. So don't do this at home, please. Don't perform this at home. This is highly what? Dangerous, because you will see that phase of your mother after you breaking the utensils. Don't do it. Telling you from the experience, right? Okay, so this is the inertia at rest, right? The utensils are at rest because of the inertia only. Okay, right? So just take a look. We have another example. Now, remembering this, there's a story behind it. I'll tell you. You take a look here. You are seeing that there is some athlete running and eventually just stepping on the ground, right? This is known as high jump. But when the lower body touches the ground, it came to rest, but the upper body is still at motion, right? So therefore he fell down some more distance. Just take a look. See, he is still moving, right? Because the upper body is still at motion, and this is known as inertia of motion. So there are basically three types of inertia: inertia of rest, inertia of motion, inertia of direction. So today, obviously, we are just discussing about the inertia here, what exactly inertia is, and I also gave you the example of inertia at rest. But yes, there are three types of inertia. Three types means basically the effect is changing, so we have distinguished the inertia. Inertia is same. Like, it is not like that inertia of motion or inertia of rest. It is not like that. It's just one inertia. But to distinguish it easily, inertia at rest, inertia at motion, and inertia at direction. It also happens with the direction. We will be discussing that. Okay. So if you take the close look here, you will see that the upper body is still at motion, right? Upper body is still at motion. Therefore, what exactly is happening? These things are happening because of the inertia only. Okay. So this is the example of inertia at motion, and this is the example of inertia at rest. Okay, so I really hope that till here the topic is discussed, and yes, don't worry about it. We have done so many numericals in the first chapter also. Just go through the playlist. You will see the videos where I was solving the numericals. Okay, just go through that and revise it. So till then, you can just study NCERT. You can go through your reference book. You can study this and keep attending the live classes. Okay, till then, take care. Bye bye.